Welcome Math 10C students. Today we're going to be starting a lesson on chapter 7. So 7.1 is all about developing systems of linear equations. So we looked at linear equations in chapter 5 and chapter 6, and now we're going to continue with these linear equations, but now be able to use them to solve some sort of a problem. So we're going to be putting two linear equations together in order to solve some sort of a problem. So first thing I would have you do, just because it's not necessarily directly in the notes in such a nice way, is write down the definition of a system of linear equations. So a system of linear equations is when we determine two linear equations, the information we're given, with two variables in order to model and solve a problem. So again, in all of these questions that we're going to be looking at, they're going to be giving us some sort of background context, and then we're going to be creating two linear equations from that context, and then be substituting in some values to figure out which values will solve the problem. So let's look at this first example here. It tells us the tickets are sold for the school play. Felix buys 3 adult tickets, and he buys 2 student tickets, and he pays $31. The second part tells us here that Ellen buys 1 adult ticket, 1 student ticket, and she pays $12. So we can use both of those sentences and put them into equation form. So just for making this question a little bit easier, we'll let the letter A represent the cost of an adult ticket, and we'll let the letter S represent the cost of a student ticket. Whatever variable you use, it doesn't really matter, but in this case, we're going to use A for adult and S for student. So let's start by making an equation from Felix's information that he gave us here. So Felix buys 3 adult tickets, so we have 3 adult tickets, and he bought 2 student tickets, so plus 2 student tickets, and the cost was $31. If we look at what Ellen purchased, she purchased 1 adult ticket, 1 student ticket, and the cost was $12. So these are the two linear equations that we come up with from the information that we were given. So you will have to be able to do that as we work a little bit further into this. You will have to be able to come up with equations based on the information given. So just make sure you read it very carefully. I think you did some of this work back in grade 9 as well. So the solution for the system, they're going to give us 2 values here, and we're going to try out those 2 values and see if they work. So far in the notes, you will be given the values that you're going to be testing out. You won't have to determine these, you'll just have to determine which are the correct values. So let's see if these values work. In order to check these values, I'm going to substitute in these values into both of the equations, okay? So if we substitute into the first equation, Felix's equation, 3a plus 2s equals 31. So anytime there's an a, we're going to substitute in 7. So we have 3 times 7. And wherever there's an s, we're going to substitute in 5. So plus 2 times 5, 3 times 7 is 21, 2 times 5 is 10. Add those together, we get 31. So that's the total on the left side, and the right side was 31 as well. So those values work for that equation. But again, in order for this to be the solution, it has to work for both equations. So let's try the other equation based on Ellen's purchase. So again, anywhere where there's an a, we're going to substitute in 7. Where there's an s, we're going to substitute in 5. So we have a plus s equals 12. So 7 plus 5, which is 12. So 12 equals 12. Perfect. So for both of our equations, the left side is equal to the right side. So a equals 7 and s equals 5 is the solution to the linear system. Now, again, the solution to a linear system is going to be those pair of values that satisfy both equations. So if the answer does not work for both equations, then it is not the correct answer. It has to work for both of them. So once you input the values, right side and left side have to be equal for both equations. Now, we're not doing it in this lesson, but graphically, we're going to be doing this in 7.2. The solution, if we were to graph these two values, is where the graphs meet. So the line intersect where the two graphs meet, that point or that ordered pair would be our solution. Okay, but we're not there quite yet. So just giving you a little bit of background information. So let's take a look at this first example here. So they want us to figure out which pair of values is the solution for this linear system. So we'll try both of them. We'll try solution A and we'll try solution B. So let's start with solution A. Okay, so for solution A, anytime there's a C, we're going to input the number 4, and for D, we're going to input the number 1. So we have to try this for both equations. So C equals 2D plus 2. So again, where there's a C, I'm going to input 4. So 4 equals 2, and then D is going to be 1. 2 times 1 plus 2. So 4 equals 2 times 1 is 2 plus 2. So 4 equals 2 plus 2 is just 4. So in this case, for the first equation, left side does equal right side. Let's try the second equation. C plus 2D equals negative 6. So let's input our values there. So C is going to be 4 plus 2 times D is 1 equals negative 6. So that's 4 plus 2 times 1 is 2. It's negative 6. So we end up with a positive 6 equals negative 6. Those sides are not equal. So this solution does not work because remember, it has to be the left side and the right side have to be equal for both sides. So let's try solution B and see if that one will work any better. Okay, so for solution B, we're going to be using negative 2 for my C value, negative 2 for my D value. So C equals 2D plus 2. That means negative 2 equals 2 times negative 2 plus 2. Negative 2 equals 2 times negative 2 is negative 4 plus 2. Negative 4 plus 2 is negative 2. So we end up with negative 2 equals negative 2. So that worked. Let's try the other equation. C plus 2D equals negative 6. So again, for the C value, I'm going to input negative 2. For the D value, I'm going to input negative 2. And let's see what we get. So we have negative 2 plus negative 2 times 2 is negative 4. Negative 2 plus negative 4 gives you negative 6. Negative 6 is equal to negative 6. You can see in both of these, the left side and the right side are equal. Left side and right side are equal. So solution B is our solution to this system of linear equations. Okay, so that's how we know that that one works because, again, both the left side and the right side are equal to one another in both of the equations. So for these, you will, again, have to work your way through to make sure your answer is correct. So they've shown you all the work there at the top of page 375. So I encourage you now to pause the video, try this check question. Oh, sorry. Try the check question, which is on the bottom of page 375 on your own, and then you can unpause the video and go through the corrections with me. So again, we're looking for which of these two solutions is the solution for this linear system. So we'll try solution A to start. So in this one, anytime there's an m, we're going to substitute negative 4. Anytime there's an n, we're going to substitute 1. Okay, so let's try with the first equation. M plus n equals negative 3. So that means my right side is going to be negative 3. And on the left side, I'm going to have negative 4 plus 1, which equals negative 3. So you can see negative 3 is equal to negative 3. So for the first equation, they did equal one another. Let's try the second equation. So m equals 3n plus 5. On the right side, we have m is equal to negative 4. So that's our constant value there. On the right side, we have 3 times 1 plus 5. 3 times 1 is 3 plus 5. 3 plus 5 is 8. So we have negative 4 equals 8. Those are not equal. So that's my, symbol for not equal. So this is not the solution. So that solution did not work because, again, it did not satisfy both equations. So let's finish off the next one. So we're going to do solution B here For solution B on the previous page, for m, they told us to substitute -1, and for n, they told us to substitute -2. So let's work through and see what we get for an answer. Right side here is -3, that doesn't change. So we have m, which is -1, plus n, which is -2. -1 plus -2 equals -3. So -3 equals -3. Let's try the other equation. So m is -1. That means this is going to be -1. On the right side, we have 3 times -2 plus 5. 3 times -2 is -6. Plus 5, -6 plus 5 is -1. So -1 equals -1. So you can see that for both of these, the left and right side are equal. That means that this is the solution to the equation. Okay, so that is the solution to the equation. Let's take a look at example number 2 here. In this one, they've asked us to use a diagram to create a linear system. So they said use a diagram to create a linear system to model this situation. So we have 8 passenger vans and 6 passenger vans carried 110 people, and there were 15 vans in all. Okay, so for part A, they've used just these different pictures to represent each type of van. So they just made the 8 a little bit bigger than the 6. We don't know how many there are of each, so hence the ... Okay, we don't know how many of each there is, so the number of each type of van is unknown, but we do know in total there are 15 vans. Okay, so in total there are 15 vans. Now they've chosen some letters here to represent each of them. So they said the 8 passenger van will be E. I think they said E for 8. And the 6 passenger van will be S. I think they said S for 6. So we know that the 8 passenger van carries 8 people. The number of people that can be carried by the 8 passenger van then would be 8E. The 6 passenger van can carry 6 people. So the number of people carried by the 6 passenger van would then be 6S. So if we put those together, we know that there's 110 people total. And this version of these include the number of people that can be held by each of the vans. So the equation we could come up with is 8E plus 6S equals 110 people. So again, even though these values are different, those both represent number of people. We also know that whatever the number of 8 passenger vans plus the number of 6 passenger vans equals 15. So we can come up with the equation E plus S equals 15. So our system that models this situation is 8E plus 6S equals 110. Remember, that's the number of people. And E plus S equals 15. Remember, that's representing how many of each type of van. So for part B, they told us they wanted us to try out some numbers. They said that there was 10 8-passenger vans and 5 6-passenger vans. So let's verify and see if those numbers work. So let's try with this first one. We have 8E plus 6S equals 110. So for this, the E value, I'm going to input 10. My S value, I'm going to input 5. Let's see if it works. 8 times 10 plus 6 times 5 equals 110. That gives us 80 plus 30 equals 110. And 80 plus 30 is 110. Okay, oh, sorry, not 100, 110. Let's try the other equation and see if that works as well. So we have E plus S equals 15. That means 10 plus 5 equals 15. 10 plus 5 is 15. So since both left side and right side are equal for both of our equations, that means that this is the solution. Okay, so that is our solution. All right, so there's an opportunity now on the next page for you to try this on your own. So I would suggest now that you pause the video and do the check question on the bottom of page 377. And then once you are finished that, You can unpause the video and watch me work through the solution so you can check your own work. So for number 1A, it asked us to use a diagram to create a linear system to model this situation. So it says a gardener bought carrot seeds for $2 a packet and squash seeds for $5 a packet. They spent $38 total and bought 13 packets of seeds. So there's kind of a couple different ways we can show this. In this case, they said the number of each type of packet is unknown. So let's have some carrot packets. We don't know how many, so we'll just draw a few here. And then these will be our squashes. Sorry, those were supposed to be a bit bigger, but it doesn't matter. Okay, so C for carrot, S for squash. And we're not sure exactly how many of each, but we know that total there must be 13 packets. So that could be our diagram for this, question. So it told us here, let the number of packets of carrot seeds be C and squash seeds be S. So each packet of carrot seeds costs $2. So the cost of C packets in dollars is 2C. Each packet of squash seeds costs $5. So the cost of S packets in dollars is 5S. And it told us above in the question that the total cost is $38. So from that, we can combine that into an equation. So we could say 2C plus 5S equals 38. Okay, and that will help us figure out how many carrots, how many squash. So now we can also make another equation. They told us above, and we drew it in the picture, the total number of packets is 13. So that means how many ever C's we have plus how many ever S's we have should be equal to 13. So our linear system that models the situation, we're just going to rewrite these equations. 2C plus 5S equals 38, and C plus S equals 13. Okay, so you can see here now that we have two equations that we can use together to determine if the solution they give us in the next question is correct. So let's take a look at the next question. For part B, it says the gardener bought 9 packets of carrot seeds, so 9 of C, and 4 packs of squash seeds, so 4 of S. Use the linear system from part A to verify these numbers. So I'm just going to rewrite my equations from the previous one. I had 2C plus 5S equals 38. That was one equation. The other one I had was C plus S equals 13. So let's substitute in these numbers and see if this is the correct number of packets of each. So on the right side for the first equation, we have 38. And then we're going to substitute in our numbers. So 2 times C is 9, plus 5 times S is 4. 2 times 9 is 18, plus 5 times 4 is 20. 18 plus 20 is 38. So 38 is equal to 38. It did work for that side. Let's check the other side. Right side is 13. We have C plus S, so we have 9 plus 4. 9 plus 4 is 13, so 13 is equal to 13. So for each of these equations, the left side was equal to the right side. That means the solution is correct. So again, nice thing about this is we are just checking to see if the numbers that they give us are correct. You're not having to come up with these numbers quite yet. You're just having to check the solutions. Let's take a look at another way that the linear system can be created. So we can also use a table to create a linear system to model a situation. So in this case, we're going to take a look at the table that they've created here. So it says a school sold 75 smoothies to raise money for charity. So total number of smoothies sold is 75. A banana smoothie, so we'll use the letter B to represent banana. A banana smoothie costs $3. A peach mango smoothie costs $5. And the school raised $625 total. So the chart they've come up with here has banana, peach, mango, and total on our row side. And then for columns, we have price of smoothie, number sold, money raised. Okay, so we know that the price of a banana smoothie is $3, peach mango is $5. From that, we can come up with 3B to represent the banana, 5P to represent the peach mango, and we know the total amount of money raised is $625. So the equation that we could come up with from that would be 3B plus 5P equals 625. If we look at the information we're given in the second column, we have our number sold, so that means how many of our banana plus how many of our peach is equal to 175. Okay, so again, from this chart we can come up, this table, we can come up with two linear equations or a system of linear equations. Now for part B, they want us to use these values to verify and see if these numbers are the correct solution. So we're just going to pop those into each of the equations. So that means for the banana, we're going to substitute 125. And for the peach, we're going to substitute in 50. And we're going to try both of those equations. I'll start with the simpler one first. So banana, we have B plus P equals 175. So banana, which is 125, plus peach, which is 50, equals 175. 125 plus 50 is 175, so 175 equals 175. Let's try the other equation. 3B plus 5P equals 625. So let's substitute those numbers in. 3 times 125 plus 5 times 50 equals 625. 3 times 125 is 375. Plus 5 times 50 is 250. And if we add those two numbers up, 625 equals 625. So we could say the solution is correct. All right. So we have verified. Now there's another check on the next page. So if you want to turn over to page 379, pause the video right now, try the check question on your own, and then you can unpause the video to see the solution to the question. So this question says, use a table to create a linear system to model this situation. They've actually already started it for us, so we just have to plug in the values. It says, one afternoon, the Winnipeg Art Gallery sold 300 adult and student tickets. So number sold is 300. An adult ticket costs $8 and a student ticket costs $6. And the total money collected was $2,000. So the only thing we need to add in here is the information for the student cost. So remember, we're going to use, they said we can use A for adult. Let's use S for student. Nice and easy. Okay, so that means the total number adult tickets, we have A, students, we have S. And a student ticket costs $6, so 6S is what we're going to put in for money collected. So let's come up with a couple equations from this. A plus S should equal 300. And 8A plus 6S should equal 2,000. So our two equations that we've come up with from our chart are A plus S equals 300 and 8A plus 6S equals 2,000. So they've given us now a solution that they'd like us to try out here. They said we have 100 adult tickets and 200 student tickets. So let's start by adding those up together. 100 plus 200 equals 300. And we know that the adult tickets are $8 each. So 100 times 8 is going to give us $800. And for the student tickets, those are $6 each. So 200 times 6 gives us 1,200. 800 plus 1,200 is 2,000. So the total number of tickets sold and money collected matched the data in the problem. If you look up above here, we had 300, 300, 2,000, 2,000. So the solution is correct. So that is the last of the practice that I'm going to do with you. The next few pages, you have from page 380 all the way to page 382. I'd like you to try those ones on your own. Again, I will post the answer keys on the Google Classroom so that you can check your answers later. And just keep in mind that this is very guided, but for your assessments, you'll have to kind of figure out how to verify, what to show. So it won't be quite as guided in the sense that you won't have all those blanks there, but this is just to get you started, okay? So try those practice questions on page 380 to 382 and use the answer keys on the Google Classroom to check your work and check back for the lesson on 7.2. Have a great day.